Hello, General Science! Happy Star Wars Day! May the 4th be with you. I'm recording this on Star Wars Day, so of course, I am going to have all my Star Wars stuff on. If you have time today to watch those movies, I highly suggest you do, because they are amazing. And that's just my personal opinion, so if you don't think that they're amazing, that's okay. I think they are, and I'm going to tell you to watch something that I love. So, happy week 4, and happy May the 4th. So, look for all my Star Wars characters in this PowerPoint today. So, last week you learned a little bit about the periodic table, what is everything that it can tell you. It's a pretty cool tool that scientists use. It's pretty amazing. So what you should have in front of you before we get started is you should have your fill-in notes ready to go. So you can start copying in those notes. Hopefully I have every word highlighted. I know I missed something last week, but that was just one word. So make sure that you are paying attention, because I might have missed some words. I might have not highlighted. But before we do that, here's just a little message from me. Which is just, hey everyone, trust me when I say that I miss all of your faces so much. This is a quick message just telling everyone to make sure that you're staying engaged in the materials that your teachers are giving you. Congratulations. If you're reading this or watching this, then you're already doing that. And I love seeing your faces, and I appreciate all of the comments that you leave. Also, I made this on May 4th, so happy Star Wars Day. I feel like I can't say that enough. Here's your to-do list for week 4. Watch the video on valence electrons and do the fill-in notes. Congratulations. You're already working on task number 1. And then you're going to complete the Lewis structure worksheet. You will know what a Lewis structure is by the end of this video. Now, before we can talk about Lewis structures, we need to talk about valence electrons. We've talked about them before. We kind of know what they are, but we kind of don't know what they are. So valence electrons are found on the outer shell around the nucleus. To determine the number of valence electrons in an atom, you need to check what group the element is in. Remember, a group is a vertical column, so up and down. You know, our alkali metals, our alkaline earth metals, our halogens, our noble gases, our transition metals, those are groups, okay? But here we're talking about one column, so I kind of goofed. I said transition metals. That's multiple columns. When we're talking about valence electrons, we're talking about one column. So yet another pattern we see in the periodic table in the main group elements only is that elements in a group have the same number of valence electrons. So whenever I ask you, hey, can you tell me how many valence electrons are in sodium? You'd be like, yes, I can, because I have my periodic table and it's in this group. We're going to learn about what groups have what valence electrons. I say main group elements only because we are going to exclude here the lanthanides and the actinides, which is those 2 rows on the bottom of your periodic table that you have. Also, transition elements. We are going to be ignoring those because they can have 1 to 2 valence electrons. It depends on the element, and it doesn't quite fit with this pattern. So we're going to talk about this pattern. So group 1 elements have 1 valence electron. So like I just said, I tell you, hey, I want to know how many valence electrons sodium has. Congratulations. Here's sodium. It's in group 1. It has 1 valence electron. Now, in your fill-in notes, I highly suggest you not only fill in this one and this one here, but you write down the numbers in the periodic table that I'm about to show you. Group 2 elements have 2 valence electrons. So beryllium, magnesium, calcium, strontium, all of these guys. Group 3, we're going to move way over here. Group 13 elements have 3 valence electrons. I called it group 3 on accident. That's group 3 technically way back in the early periodic table days, back when I was in high school, which is years ago. These columns were also labeled 3A, 4A, 5A, 6A, 7A, and 8A. Now, this might happen in some of the periodic tables if you just look it up, so just be aware. Group 14, Who am I blocking? Oh, it's Han Solo. Group 14 elements have 4 valence electrons, so carbon, silicon, germanium, tin. Group 15 have 5 valence electrons. Group 16 has 6 valence electrons. Group 17 has 7 valence electrons. And hopefully you can guess this pattern. Group 18 elements have 8 valence electrons. So we're starting to see a pattern here. We have 1 valence, 2 valence, 3, 4, 5, 6, 7, and 8. Those are valence electrons. So what does that even matter? So I can't get it any smaller. We have this rule. It's called the octet rule, and it's more like a guideline. And when you take chemistry, you will understand why it's a guideline. But this is a guideline. Most elements actually don't follow this rule, but for you guys, we're going to pretend that it's a rule. And it's called the octet rule. Now, octets kind of sounds like 8, and that's because atoms prefer to have 8 valence electrons in their outer shell, even though like sodium only has 1. Carbon has 4. They prefer to have 8. And when they have less than 8 valence electrons, they will bond with each other or with other elements to have 8 valence electrons. Sometimes atoms will lose electrons to drop down to a full lower energy shell. Remember your Bohr model. If we look, everything has different kind of electron clouds. Well, sometimes if one electron cloud isn't very full at all, an element will lose that electron and will go back down to this like full outer cloud or outer shell. Or they will gain electrons to fill their valence shell. This is why noble gases, which are in group 18 and have 8 valence electrons, are happy and will rarely react with other elements. That's because they have 8. They're not going to lose any electrons. They're not going to gain any electrons. They don't want anything to do with anybody. They're happy the way they are. So let's talk about what a Lewis dot structure is. Okay. A Lewis dot structure is a diagram, and it's a way of representing valence electrons in an element. 1 dot is equal to 1 valence electron. The element symbol goes in the middle. Electrons 1 through 4, so we could have valence electrons of 1, 2, 3, or 4, go on 1 dot per side. Electrons 5 through 8 now create pairs. So our example here, we're going to use calcium, which is in group 2, which means it has 2 valence electrons. Calcium, the symbol goes in the middle, and we imagine that there's a box. I wonder if there's never mind. I thought I could write on it. Imagine there's a box around calcium, and this box is where the electrons are going to go. So I'm not going to put an electron over here on the corner or over there. They just go on the sides. Now this only has 2 valence electrons, so they're placed 1 dot per side. 1, 2. Let's look at an example where we have more than 4 and that they actually have to pair up. I wish I could block me. I kind of can. So how to draw Lewis structures. In oxygen, first thing you need to do is find oxygen on your periodic table. I don't even have my periodic table in front of me, but you need to find it. And you say, oh, it's in group 16. So you're finding out what group number the element is in. You know that oxygen is in group 16, therefore it has 6 valence electrons. 6 valence electrons, which means I had to count them. That's more than 5, so we're going to have some pairs now, or more than 4. So here we go. We have electrons 1, 2, 3, and 4 right here. These are all 1 per side. Now, electrons 5 and electrons 6 actually pair up. And this is what we mean by pair. And they're happy. These guys are all alone by themselves. And these guys are happy here. 1, 2, 3, 4, 5, 6. We have all 6 valence electrons. We just put them in 1, 2, 3, 4, 5, 6. Just like that. Of course, you get to practice on yourself. So, pause me right now. If you want to try and do this all on your own, push pause. And then all of a sudden, when you push play, you will be able to figure out if you were right. So pause me. Try it. You're trying it? You're not trying it. I'm still playing. Okay. So what you need to do, go to your periodic table. You need to find hydrogen. Hydrogen is in group 1. which means it has one valence electron. That valence electron can go anywhere around this hydrogen. I put it here though. But that's it. We're done. There's our Lewis diagram. Okay. Now let's move on. I think I did boron next. So boron is in group 13. That means it has 3 valence electrons. So I'm going to put one on either side of my boron. I'm not going to pair them up. And that's exactly what I did. 1, 2, 3. They are not paired. We don't see 1, 2, and then 3 electrons. 1 through 4 go all the way around before we start pairing them up. Now phosphorus is different. Phosphorus is in group 15, which means it has 5 valence electrons. So I'm going to have to create a pair. Now, the way I would do this is 1, 2, 3, 4, 5. And that's exactly what I did. So here's my 5th electron here. Oh, no! Here's my 5th electron here, counting through so I can have this one paired up, but these 3 are all by themselves. Now, you might have already seen it, and I should have paused it and probably edited out of this part, but. We're going to talk about it anyway. So argon is a noble gas. Argon's happy. What makes it happy? It has 8 valence electrons, which means I'm going to put my electrons 1, 2, 3, 4, 5, 6, 7, 8. Boom. Everything is paired. Everything is happy. We don't have any electrons by itself. This electron by itself here and here and here and there and there and there and there all make our elements sad. And those sad elements want to bond with other elements. And we'll talk about bonding a lot next week. What I want you to do this week is just practice Lewis dot structures. Practice identifying protons, electrons, and neutrons in the periodic table. So congratulations, you're done. This was a very simple, very straightforward, very short video. What you need to do next. Once you've turned in your notes, get started on your practice. If you have questions or you want to say hi, send me an email and we can set up an appointment. And when I say an appointment, that just means you are sitting in front of your computer, video chatting, you and I are talking, and I can just easily answer a question. Even if that question will take 2 minutes long. Set up an appointment, we'll Google Meet, and then you're done. And you can hang up as soon as you're done and have all your questions answered. Okay? Okay. Well, goodbye, General Science. Have fun doing Lewis dot structures. I hope you have as much fun on Star Wars Day as I am going to have. Remember to email me with questions that you have and all of that fun stuff. Other than that, may the 4th be with you. And I need to exit my slides. Wait for it. Wait for it.